Students, welcome back to Maths online class. In the last class, you have learned irrational numbers and representation of decimal representation of rational numbers. In the last class, you have learned irrational numbers and decimal representation of a rational numbers. What is irrational number? An irrational number is a number that cannot be expressed as an ordinary ratio of two integers. Irrational number is a number that cannot be expressed as an ordinary ratio of two integers. Example, root 2, root 5, pi, etc. Next, decimal representation of a rational number. In the decimal of p by q, when the remainder is 0, the decimal expansion is called terminating decimal. Example, 1 by 2 is equal to 0.5. Next, in the decimal expansion of p by q, when the remainder is not 0, we have a repeating block of digits in this quotient. The decimal expansion is called non-terminating and recurring. Example, 1 by 3 is equal to 0.333, etc. Okay. Next, in the previous class, I have taught represent the following as decimal form. First question I have completed. Second question I told you to complete it. If you not complete that, once again I am teaching. Please listen here. First, 11 by 75. You want to write this in the decimal form. 11 by 75. 11 inside you have to write 75 outside. Now we check this number. This 11 is less than 75. 11 is less than 75. So you have to write 0 point. Then here also you have to write 10. So first 1 times 75 will be get 1 times 75. Here 0 balance. Here 10 will be get 10 minus 5 is equal to 5. Next here 0, here 1. So 335 is the remainder. Next one more 0 we have to include here. One more 0 including times. How many times will be get? 75 into 4 times means 5 times means what will be get? 7 times 7 5 is 35. More than 350 will be get. So 4 times we can take it. If you are taking 4 times, 5 4s are 20. Next 2 balance. 2 balance. 7 4s are 28. 28 plus 2 30. 300. So 4 times 300 will be get. Next, subtracting time. 0 minus 0. 0. 5 minus 0 is 5. Next again, we have to include 0 here. So how many times first? 75 into 6 times means 5 6 are 30. 3 balance. 5 6 are 30. 3 balance. Then next 7 6 are 42. 42 plus 3. 42 plus 3, 45. 450 will be get. If you are taking 7 times, more than 500 will be get. So we can write 6 times 450. And we are subtracting 0 minus 0, 0. Here 4. Next here 10. 10 minus 5 is 5. Next 4 minus 4, 0. Again we have to include 0 here. 0 including time. Next again how many times? 6 times 450. Next subtracting time. 0 minus 0, 0. Next 4. Next here 10 will be get 5. Again 0 including times. Again 6 times 450. It will be continue. Again remainder is 50. Again when we are taking 6 times. Here the remainder is not 0. Here the remainder is not 0. We are getting repeating block. So this we can say that not terminating at requiring decimal expansion. So this 11 by 75 we can write it 0.1466 etc. or we can write 0.146 only repeating again and again. No other 1 4 is not repeating. Only the digit 6 is repeating. See, we can write 146 bar. Above the 6 only we have to write bar. Okay, represent the following as decimal form. First 11 by 75. 11 inside, 75 outside and divide it. So 0.14666 etc. like that we are getting. So 0.146 bar like that we can write. This one non-terminating and requiring decimal expansion. So 11 by 75 has non-terminating and requiring decimal expansion. Next we can go for the next problem. Exercise 2.2. First problem. Express the following rational numbers into decimal and state the kind of decimal expansion. Express the following rational numbers into decimal. We have to convert these rational numbers into decimal and state the kind of decimal expansion. Which kind? Requiring, non-terminating and requiring terminating decimal expansion, like that we have to find out. The first question, first is second question. Second question, minus 5 3 by 11. Minus 5 3 by 11. First we have to convert. This is a which one? Mixed fraction. This is a mixed fraction. First we have to convert this into improper fraction. How can we convert this into improper fraction? First we can write this minus. Next, these two numbers we have to multiply. 5 into 11, 55. 5 into 11, 55. Plus 3. 55 plus 3, 58. By 11. This is the which one? Improper form of this mixed fraction. Improper form of mixed fraction. Next we have to divide this. Minus 58 by 11 we want to divide. Dividing time what will we get? 11. First how many times it will be gone? Yeah, 5 times 55. Next how many balance? 3 balance. 3 balance. Next, any other digits are there? No. So what we have to do? Yes, we have to the point and include 0. Next, how many times it will be get? 2 times 22. Very good. Next, cancelling time. Here 2 will be get. Here 10 will be get. 10 minus 2 is 8. 0. Next, how many times? 7 times 77. Next, how many balance is there? How many balance is there? Yeah. How much? 3 balance will be there. Here 7 will be get. Here 10. So 3 balance will be there. So how much balance? Here 30 will be get. Next, how many times? 2 times 22. Again, how many balance? 80. Then again, what will be get? 7 times 77. Again, how many times? 7 times 77 will be good. So, here we can write it 5 minus 5 3 by 11 is equal to minus 5.2727 etc. That is equal to minus 5.27 bar. Minus 5.27 bar. Here 2 7 is repeating again and again. So the remainder is not getting 0. 2 7 like that, repeating again and again. So this 5 minus 5 3 by 11 has non-terminating and requiring decimal expansion. Therefore, minus 5 3 by 11 has non-terminating and requiring decimal expansion. Therefore, minus 5 3 by 11 gas, it is going at 2 7 like that, repeating. So we can write it has non-terminating and requiring decimal expansion. Then the fourth problem. How can we do that? Fourth problem, 327 by 200. First, what is the smallest number? In first numerator we have to write it inside, 327. 200 we have to write it outside. So first 2 times 200 into 2 means 400 will be get. So we can write 1 times 200. 1 times 200. What is the balance? Here 7, here 2 will be get 127. Next here what we have to do? Any other digits are there? No. So we have to write point. Here put point and 0 have to write it here. Next how many times? 200 into 5 means 0, 0, 5 2s are 10. So 5 times 1000 will be get. 5 times 1000 will be get. Subtract it. So 0, 7, 2. Again we can include 0. So first next for 6 times means 0, 0, 1, 2000, 200 will be get. So 6 times 1, 2, 0, 0. Next subtracting times 0, 7. Next one more 0 include here. So how many times? 3 times 600 will be get. 3 times 600. Again we can write it, subtract it. 0, 0, 7 minus 6 is 1. Next one more 0 included. So how many times? 5 times means 1000 will be get. 5 times 1000. 0 is the remainder. So this 327 by 200 is equal to 327 by 200 is equal to 1.635. What is the answer? 1.635. 1.635. We are getting the remainder 0. Therefore, 327 by 200 has terminating decimal expansion. Therefore, terminating decimal expansion. Have you understand? If you are getting the remainder 0, not terminating decimal expansion. If you are not getting the remainder 0, non-terminating and requiring decimal expansion. This one, period of decimal. In the decimal expansion of the rational numbers, the number of repeating decimal is called. The number of repeating decimal is called the length of period of decimals. For example, 1 by 3 is equal to, we know that 0.333, etc. Here which digit is repeating? 3 is repeating again and again. So we can write 0.3 bar also. Here the length of the period is equal to 1. Only one digit is repeating again and again. So we can say the length of the period of the 1 by 3 is equal to 1. Here once again the length in the decimal expansion of rational numbers. Decimal expansion of rational number. The number of repeating decimals, which digit is repeating, is called length of the period of decimals. We can study one problem here. Exercise 2.2, second problem. Express 1 by 13. 1 by 13 in decimal form. Find the length of the period of decimal. We have to find out 1 by 13 in decimal form. Find the length of the period of decimals. So how can we do this problem? First 1 by 13. 1 by 13. 1 we have to write it inside. 13 we have to write it outside. 1 by 13. First, which is the smallest number? 1 is smaller than 13. So, okay, 13 is greatest number. 1 is smaller number. So, what we have to do it? 0 point. Here also 0, write it. Now also check it. 10 is getting. 10 is less than 13. So here also one more 0, write it. Here also 0, write it. Now 100. 100 is greater than 13. So how many times 13 into which times? 6 times means what will we get? 6 3s are 18. Next one balance 78. 78 is less than 100. So we can go for the next number. Next 7 means 7 3s are 21. 2 balance 1 7 is 7. 91. So 7 times means 91 is getting. 7 times 91 is getting. So subtract it. 0 here 9 will be get. Here 10 will be get. So 9. Next 9 minus 9. 0 will be get. 9 is getting remainder. Next again one more 0. We can no other digits. So 0 we have to include here. How many times? 6 times 78 will be get. 6 times 78 will be get. Next subtract it. Here 8 will be get. Here 10 will be get. 10 minus 8 is 2. Next 8 minus 7 is 1. 12 is getting remainder. Once again next again we can write it 0 here 0 writing times. How many times? 13 into 9 times means what will be get? 9 times 7 9 3s are 27. 2 balance. Next 1 9 is 9. 9 plus 2 is 11. So 9 times what is getting? 117. Next subtract it. Here 1 will be get here. 10 will be get. 3 is the remainder. Next 0. How many times? 2 times 26. Next subtract it. 10. So what will be get? 4 is getting. Next 0. Next. So how many times? 3 times 39. Next how many balance? 1 balance 0. It will not go 0 again. So here we have to write it one more 0. How many times? 7 times 91 will be good. 7 times 91 will be good. Now we check it 0, 7 again. When we are taking what will be get? 6 will be get. Again what will be get? 9, 2, 3. So it will be repeat. Again will be get 0, 7, 6, 9, 2, 3. So what is the decimal expansion of 1 by 13? 1 by 13 is equal to 0.076 923. bar. So here how many digits are repeating? 1, 2, 3, 4, 5, 6. 6 digits are repeating. Here 6 digits are repeating. Therefore, length of the period is equal to 6. Therefore, length of the period is equal to 6. Next we can go for example 2.3. Next we can study example 2.3. Example 2.3. Express the rational number 1 by 27 in recurring decimal form. We want to find out this 1 by 27 in recurring decimal form by using the recurring decimal expansion of 1 by 3. And we want to be use the recurring decimal expansion of 1 by 3. Hence write 59 by 27 in recurring decimal form. First we have to find out the decimal expansion of 1 by 3. 1 by 3 is equal to, first 1 by 3, decimal expansion of 1 by 3. First 0 point, is it 0 point? Next 10, 3 times 9 will be get 1 balance 0, 3 times 9 will be get again 1 balance 3 times 9. So we can write it 0.333 etc. or what we can write 0.3 bar. 0.3 bar. 1 by 3 is equal to 0.333 etc. or 0.3 bar. Next we have to find out by using this 1 by 3 we want to be find out the decimal expansion of 1 by 27. 1 by 27 is equal to, first 1 by 27 how we can split it? 9 into 3 only 27. 9 into 3 only 27. So we can write it 1 by 9 into 1 by 3. 1 by 9 into 1 by 3. Already we know the decimal expansion of 1 by 3. That is 0.333 etc. That value we have to be used here. When we are using that, what we are getting? 1 by 9 into 0.333 etc. When we are cancelling, what will we get? When we are cancelling 3 times 3 table we can cancel. Next 0.111 etc. 0.111 etc. Next we have to be divide this. Dividing time 0.111 divided by 3. 0.111 divided by 3. So first is 0. First digit take it 1. 1 is less than 3. 1 is less than 3. So you have to put here 0. Then only together 2 digits together you can take it. Now 11 together take it. How many times will we get? 3 3s are 9. 3 3s are 9. 3 3s are 9. How many balance? 2 will be get 7. Next. So how many times? 7 times 9 times. Sorry, 1 7 times 21 will be get 7 times 21 will be get. Next the remainder is 0. Next 1 take it. 1 take in time it will not go 0. Next what will be get? Next digit also take it together. How many times? 3 times 9 will be get. Next 2 balance 7. Next 1 7 times what will be get? 21. Next again 0 remainder. Next again it will be continue this. So what is that? 1 by 27 is equal to 1 by 27 is equal to 0.037 or 0.037 bar. 0.037 or 0.037 bar. So we can, what is the decimal expansion of this? 1 by 27 is equal to 0.037 bar. Next, we using this, we want to find out the decimal expansion of 59 by 27. 59 by 27. Next, 59 by 27. First, we want to convert this into mixed fraction. How can we convert this into mixed fraction? 59 by 27. How many times? 2 times. 27 into 2 means 54. 2 times 54 will be get how much balance? 5 balance. 5 balance will be get. So 2 5 by 27. What is getting the 2 5 by 27. Next, that is equal to this one. Again we can split it. 2 plus 5 by 27. 2 plus 5 by 27. It is equal to 2 plus 5 into, this one we can split it 5 into 1 by 27. Why we are splitting like this? Already we know the decimal expansion of 1 by 27. Here we are using the decimal expansion of 1 by 27. So we are getting 2 plus 5 into 0.037 etc. When we are multiplying, what will we get when we are multiplying? Three seven zero 37 into 5. 5 times 7 5s are 35. How many balance? 3 balance. So 5 3s are 15. 15 plus 3. 15 plus 3. 18. Next 5 into 0. 5 into 0. 0. 0 plus 1. 1. Next 7 5s are 35. 3 balance. Next 5 3s are 15. 15 plus 3. 18. How many digits before want to put the decimal point? 1, 2, 3, 4, 5, 6 digits we want to before we want to put decimal point. 1, 2, 3, 4, 5, 6. 6 digits before we want to put the decimal point. So we can write 2 plus 0.185 etc. So 2 plus 0.185 etc. That is equal to 2.185 etc. Or we can write 2.185 bar also. 2.185 bar also. What we have to do first? 1 by 3 is equal to 0.33 etc. Using this we want to find out 1 by 27 is equal to 1 by 9 into 1 by 3. That is equal to 1 by 9 into 0.333 etc. By cancelling this we will be get answer 0.03737 etc. This value we have to be used here. Then we are getting the decimal expansion of 59 by 27. 59 by 27. Now homework problem. You have to do the homework problem. Exercise 2.2 first problem. Express the following rational numbers into decimal and state the kind of decimal expansion. First I taught that the same model 2 by 7 and 22 by 3. First we want to convert this into ration which form? Decimal format, state the kind of decimal expansion. Next third question, Express the rational numbers 1 by 33 in recurring decimal form. We want to find out this into recurring decimal form by using the decimal expansion of 1 by 11. First you want to find out the decimal expansion of 1 by 11, and by using this you want to split 1 by 33, 1 by 3, 1 by 3 into 11, like that you want to split it, and you want to find out the answer of 1 by 33 and write 71 by 33 in recurring decimal form. So you want to do these two problems as a home assignment. I hope you all understand this problem everything very clearly. So you do the homework problem. Next class we can meet. Thank you students.